Is the sound working? Sweet, sweet, sweet. 4 more days of these tutorials and then I can finally get some sleep for a change. Alright, we'll just wait for a couple of minutes, guys, and then we'll kind of get started. Khalil, is there a mic delay? Testing. Fair enough. Now I saw the paper for level 2. I thought it was a bit of a weird paper, right? Because it was like I saw lots of easy achieved in merit questions, and then yeah, the excellence questions were a bit different. Like I definitely would need a bit of time to think about how to explain it. Well, I'm glad you thought the calendar question was cool. Level 1 I've not heard. Like I think level 2 a lot of kids came back and said it was like crazy hard, but like level 1's wasn't that much today. I know one of the guys that I was speaking to, he said that the excellence question was the bearing ones was pretty straightforward. Yeah, the octahedron. Yeah, again, like look, I think it's just like a set of you just got to use a set of Pythagoras to try and solve that. Yeah, so yeah, I thought bearings, someone said the bearings question was pretty straightforward. Ziad, are you doing complex numbers as well? Right. Fair enough. Reciprocal polynomial. I heard about the reciprocal polynomial, but anyway. All right, guys, look, it's 7:40. Like I said, we're going to kind of do the merit questions first. And then what I'm going to do is I'll probably stop the stream, take like a 10-minute break, and then I'll come back, put another new stream up because I know that some of the guys that are coming later on in the nights, like they want to kind of work through the excellence questions and skip the merit ones. Can I self-promote an open source NCEA past paper scraper on GitHub? Oh, who knows? Anyway. All right, guys. So here is our first question for the night. Like I said, we're going to be doing merit questions for the rest of today. Well, not rest of today. We're going to do the 6 merit questions. And once we finish the 6 merit questions, we're going to go into the excellence questions. Now, with the merit questions, what I tend to do is I kind of give you guys a couple of minutes to have a go by yourself. And once you have a go by yourself, then I'd actually start working on it. So this one, I'll actually go through the answer at about, what's the time right now? 7:41. So maybe I'll go through the answer at 7:43. But what I want to know is, can I actually make this any bigger? Sorry, I'll come back to the question if you haven't copied it. Oh, you can. There we. Oh, damn! It's just that page. Give me 1 second, guys. I just want to make this a little bit bigger. Control Z. Is that gonna work? No, of course not. It's not gonna work. Control A. Okay, that's gonna work. And no, it's only gonna let me do 1 page at a time. That kind of sucks. Yeah, can't be stuffed. You know what? Let's just work with what it is. What happened now? It's coming. It's just taking its sweet old time to load up. Angus, I did see the level 2 paper. Oh, no worries. You're welcome, Tharon. Not a problem, man. I guess I'll see you at next year's level 2 tutorials, mate. Alright guys, I'm going to give you guys one more minute and then I'll start chipping away at this question, alright? Where is... Now, the reason I wanted it bigger was because it's like the pen, as I start writing it, it just becomes a little bit more annoying. So I'm just going to move it out a little bit. Yeah, that's much better. Yeah, Eliane, I did look at the level 2 paper. I thought it was just one of those papers where like the achieved merits were pretty straightforward, but the excellence was a little bit tricky. But anyway, look, let's get through with this question. By the way, I do have a quick question to ask. Like, for those of you guys that are actually attempting these questions, do you want some time to work on your own, or do you just want me to do like just like rush it out and get all these 6 questions done? What do you guys want me to do? Do you guys want some time to actually work on your own, or do you want me to just go through these questions real quickly? Let me know. I'm happy with either. Okay, that's fine. Shall I start going through this question yet, or do you guys need a bit more some time? See you next year, Alian. Okay. All right, we're going to start this question. So the first thing about this question is that I want to get rid of the square root symbol. So what I'm going to do is I'm going to write this as 5 minus root x squared equals to square root of x minus p squared. Now, when I actually do this, what happens is that I'm actually going to end up with 5 minus root x times 5 minus root x equals, now this part here, the square root symbol actually disappears, and what I'm left with is just x minus p. Now, this is one of these questions where you actually have to rearrange and then get rid of the square root a second time. So we're going to expand the brackets. We've got 5 times 5, which is 25, minus 5 root x minus another 5 root x, and then we're going to get plus root x times root x is positive x. And on the other side, you've actually got x minus p. Now the question does say you need to write x in terms of p, so we've got to write kind of bring all x's together and then get rid of the p. Now the first thing I want to be doing here though is I can kind of see there's an x on both sides, so I'm going to get rid of those 2 x's, and what I've got here is 25 take away 10 root x is equal to minus p. So at this point I want to have x by itself, so I'm going to have negative 10 root x equals negative p minus 25. I'm just going to write that in a different color because I know that you kind of always wonder what happened. Then I'm going to get root x is equal to negative p minus 25 divided by negative 10. And finally I can now square both of these sides. So I'm going to actually square this, and I'm going to square this, and what I'm left with is x is equal to negative p minus 25 divided by negative 10 squared. Now you might have actually seen that as p plus 25 over 10. That's fine as well. So I'm going to put some line numbers as always, and you guys can tell me if there's any particular line that didn't actually make sense. grades wise, you're looking at third line is going to get you achieved, which is probably this one here, is where you're going to be looking at achieved, and then you're going to get merit for the final part of this question. No worries, Creator Ducky. I'll see you next what do you call it, next year for level 2. If you guys are okay with this, let me know. We can move on to the next merit question. Otherwise, we will yeah, I think we're okay with this. It's pretty straightforward. Nice question here. All right, we'll go to the next one then, which is going to be question D. And as we were saying, I'm going to give you guys a little bit of time. So maybe I'm going to give you guys about 3 minutes for this. So we'll go through this at 7:51. So have a go at this question here. And by the way, for this question, you do have to show your working. So you can't just plug it in the calculator and be like, yeah, I'm done. Unfortunately, it doesn't actually work like that. So you have to make sure that you can actually show all of your working as well. But I will show you guys some shortcuts on how to do this with the graphics calculator, so that you're not like, how do I say it? So there are some shortcuts of how to do this as well. So oh man, 7:51. All right, no worries, SPN3V. So hopefully you guys had some time to kind of like chip away at this question. So we'll kind of start doing this slowly at the moment. All right, so what do we have here? So we've got w equals to 1 plus 2i, and we've got to find the value of w squared plus w over w conjugate, and we've got to actually give the answer in a plus bi form. All right, now they do say that you've got to clearly show your working, and because they show that that you kind of have to kind of like do a little bit of cheating here, but I'll show you what I mean by cheating. Because all you're going to do is you're going to go w squared, which is 1 plus 2i squared, plus w, which happens to be 1 plus 2i. And then what we've got is divided by the conjugate, which is 1 minus 2i. Now we want to make sure we set up this question first. Once we set up this question, the next step I'm going to do is I'm going to write this as 1 plus 2i bracket 1 plus 2i plus 1 plus 2i, and I'm actually going to go 1 minus 2i and multiply it by its conjugate. So this will be 1 plus 2i and 1 plus 2i. Now, even though they actually tell you guys that you must clearly show each step of your working, You can, because what you can do is you can basically go, well, you know what, this is my working. But what you can really be doing is you could actually go into the calculator and actually do this as 1 plus 2i. So I'm going to put that there. I'm going to put that as 1 plus 2i squared. So that's going to be negative 3 plus 4i. So I'm going to write this as negative 3 plus 4i. Plus, in the numerator there is going to be negative 3 plus 4i as well. And then we're going to divide it by 1 times 1. Well, that's just going to be 1 minus 4i squared. So with that in mind, we can kind of just go, I'm going to have to kind of work here. Negative 3 plus 4i plus negative 3 plus 4i. And that's actually, the denominator is going to be going up to 5. Kind of keep going. And at this point, I would almost say you could actually rewrite this as, basically you collect the real parts. So negative 3 plus 4i minus 3 over 5 plus 4i over 5. So this will then become negative 3 3/5 plus 4 4/5 I. And basically that's going to get you that merit grade right there. So let me know if that's okay, and I'll actually put up some line numbers again. And again, like, that is pretty much all you kind of need to do. I mean, you can kind of do that in the calculator real quickly, but you can also just kind of show the working, but then you do the working in the calculator and bring it up. Yeah, I mean, like, you kind of notice, right? Like, I mean, like, when you start doing the complex numbers questions, you kind of will notice that it starts to become very easy when you start doing like the what do we call it, when you start doing the excellence questions. Now for achieved, you either need to get this part here correct, or you need to get this part here correct for achieved. So that's what you're looking at for achieved. All right, guys, if that's okay, let's go to the any questions on that one, or are we all good with that? When collecting like terms. Well, it's a fraction, right? So I actually went through 4 plus 4/5. So when it's 4 plus 4/5, it just gets added up, because if you think about it like this, if I do 4 plus 4/5, this is the same thing as saying 20 over 5 plus 4 over 5, which equals to 24 over 5, which then as a mixed fraction is 4 4/5. Okay, cool. Next merit question we're going to go, which is this one here. And I have to say, this is probably one of my favorite questions when it comes to complex numbers, is when they actually do complex roots, because it is one of my favorite questions. What I'm going to do is I'm going to give you guys maybe a couple of minutes again. We'll go through the answer at about 7:58, maybe. No, 7:50. No, you know what? I'm only going to give you guys still about 7:59. Let's do that. 2.5 minutes to do this question, guys. No, I don't do stats, Kate, unfortunately. So never really got into it. Well, actually, I was into it quite a lot before, during year 13, like before 2013. I was doing a lot of stats, but then after that I got, yeah, I just started doing calculus after that. Just enjoyed it even more. I teach at Almost in Junior College. No, I've not, Eric. I've not actually seen it yet. Normally, because I'm at a junior college, I don't actually get the papers. So like before, I used to be in I used to be in a senior college, and then because I was in a senior college, I used to have a look at all the papers and stuff like that. But now, because I've gone to junior college, it's been a bit yeah, it's been a bit weird, because it's like I haven't actually got any papers yet. Ben, look, I'm gonna be super honest with you, Ben. Like, I'm gonna be doing the complex numbers questions today. Maybe in the weekend I might do a couple of big marathons, like merit marathons, to try and help you guys out. But I'm not going to be doing any, because I've got to do excellence questions after these next 4 merit questions, which I'm hoping to kind of power through in the next few minutes. But yeah, I'll definitely do differentiation. I mean, maybe the 2013 series, I'll do it later. Why did you go to junior college when you teach senior things so often? Real simple, Adi. Like, I really enjoy teaching senior college, but I, like, to be honest, I got a little sick of like the whole like people like doing just enough for merit excellence, and like I just got sick of NCEA, to be honest. But with this, it's like I get to do what I want to do when I want to do. I don't have to like worry about your guys' exams or anything like that. I mean, I do worry. I mean, in a way I worry, but in the other sense, like, for example, like, we have to write reports if X number of students actually fail the exam. We've kind of gonna go, oh, why did we fail the exam, what changes we're making, and all of that. But here it's like I can do what I want to do without having all that paperwork. So there you go, that's what it is. It's the paperwork. Look, it's 7:59. Let's go through this next question. My kind of thinking about this question is that I always start with drawing a very quick graph. So I'd basically go, this is negative 8k6, so that means it is real, so it is going to be somewhere here, negative 8k6. And of course the angle that it's taking is going to be 180 degrees. So my z cubed is going to be written as positive, because the modulus is the distance between the center and the point itself. So that's why it's going to be a positive 8k to the power of 6, cis 180 degrees. Now this particular question I'm going to do in like about literally 3 steps. I think that's all it's going to take. Now, because I have Z3 means there's going to be 3 roots, and each of those roots are going to be with a difference of 120 degrees. All right. So that means my first root, Z1, is going to be 8k6 to the power of a third, cis 180 divided by 3. So Z1 equals 2k squared, cis 60 degrees. Now, from this point onwards, I literally do this, guys. Because it's Z2 and Z3, it's going to have the same modulus, 2k squared, but the angle is just going to change. Every time I'm going to add angle 120 degrees to it. So this will become 180, and this will become 300 degrees. And basically, I am done with this question, because that's going to get me a merit right there. And I think if you get 1 correct solution, you will get an achieved. Michael, I've actually seen it come once or twice with De Moivre's theorems. It becomes like a, I saw it pop up, and then it turned into like kind of like quadratic, like something like that. It changes. Yeah, Ravine, it's funny, right? Like, I mean, like, you're gonna get a complex roots question. Like I don't think I've ever not seen a year without complex, unless they have to. No, John Doe, you can actually leave it in degrees. And I prefer working in degrees because it's actually easy to do that end adding. So I'll just do the adding of 120 degrees. Now, if you did this in, what do you call it? If you did this in radians, you would have to be adding 2 pi divided by 3, and it can just get a bit complicated. And when you're sitting 3 exams, some of you might be sitting 3 exams, you really want to save time. And complex roots, I would strongly recommend you guys to work in degrees, because you can just kind of do it real quickly, and be done with it. Like, seriously, I mean, that took like 2 minutes, less than 2 minutes for me to do that merit question. And also, by the way, if you are watching, you know, kind of thinking, oh, I'm going to struggle with complex numbers, try and learn this particular question, and you should be pretty much good to go. All right, next question, D. O'Day, I would love to do it. Like I said, I'm on a mission today. I want to try and finish this paper by 8:30, and if we finish it before 8:30, I can do one more complex roots. All right, the next question is this one here, and again, I am going to give you guys whoa, where did it go? There it is. Yep, I'll leave this question up here, and I'm gonna, why is it happening? Something's happening. Wait on, hold on. Yeah, there we go, that's much better. So why do I sometimes do, what's happening, man? Like my thing is just getting very buggy. Give me a second, guys. I'm just gonna restart the thing. Restart the notebook. All right, to answer your, this is like trippy because it's like it doesn't want to leave, it doesn't want to do that question. I don't know why. Is it because of this? Is it gonna work now? If I zoom just a little bit, there you go. If I leave it like that, is it gonna work? Yes, it's gonna work. To answer your question about that ravine, if you think about it like this, right? When you look at 270 degrees, 270 degrees is actually doing this. So that is actually going anti-clockwise, which means that's going to be 270 degrees. But the problem is when you go 90 degrees the other way, that's why we call it minus 90 degrees. So if you think about it, 270 degrees and minus 90 degrees is the same thing, except minus is actually going clockwise and the positive one is actually going anti-clockwise. So you can actually put it in either. As long as your answer is between 0 and 360, you're pretty much good. Yeah, I think this is another thing that, as King Zag is actually saying, like if you have proof questions that are merit, you gotta go at it straight away, man, because you gotta be like, well, this is like, you know what the answer is. All you gotta do is just try and prove it. So with this question, again, they've actually said you must show all your working. And I'm gonna start working on this right now because I don't want to just kill Aaron. As I said before, we'll do a complex roots at the end. If we finish before 8:30, I'll put up another complex roots. All right, so what are we going to do is we're going to do this as 4 plus 2i divided by 1 plus I, and we're going to multiply by 1 minus I and 1 minus I and the modulus. We're just going to leave it as it is for now. All right, now the numerator, what I'm going to do for the numerator is I'm actually going to use the calculator. I'm not, like, again, like I said to you guys, as long as you show your intent, like in this case, I'm actually showing that this is my step that I'm doing next. So 4 plus 2i times 1 minus I. And what I'm going to get here is 6 minus 2i. And that's divided by 1 plus I minus 1i. So whatever that is. So it's 1 minus I squared. So I'm just going to do that as a bit of a thing. So you got 6 minus 2i divided by 1 minus minus 1, and we're getting 6 minus 2i divided by 2. So we're going to get 3 minus I and the modulus of that. Now the modulus of that is, of course, you take the real part, which is 3 squared, plus the imaginary part, which is negative 1 squared, and then you got to take a square root of that. So there we go, 9 plus 1 equals 10, and nice merit right there. Any questions with that one, guys, or are we happy to kind of like move on to the next question 3? Question 3C. We're actually doing pretty well. Like I think we'll definitely get another complex roots in there. Do you have any questions with this one? Otherwise, we can just move on. Yeah, like I think that'll be good, right? Like getting questions like this. All right, this is my other kind of like question that I've seen pop up a few times, or one of these combinations of this, right? So I will leave it up here for you guys to have a go at. So who was it? Last year there was a guy that I was working with, and I think he's no longer doing this, but he was in level 3 last year. His name, and you know what? I actually remember his name. So I don't even know if that's his real name, but there was a guy called Jonathan Watkinson, and he actually came up with a shortcut of how. I'm looking at your question, Adi, of how to actually convert those questions into ellipses or circle or whatnot. And the way he showed me was you go into a graphics calculator and you go into conics. All right, and if you go into conics, what happens is you find the equation that you think it is. Like, see how it's this in this format here. So you could actually put your equation in that format, and it actually kind of, in a weird way, tells you where the center of the circle is and so on. JJ, we will be doing excellence question at 8:45. I should put that up here, which I thought I did, but can I just add source text? Yeah, I can do. Oh, there we go. Look at that. I can add a text here. This is gonna work. That's the question. Excellence questions at 8:45 p.m. Is it actually showing up or no? Font. No, I want this in red. Okay, that's like way too big. Hang on. Sorry, I'm just trying to adjust this. Sizing fixed. Okay, there we go. Let's move that somewhere. There we go. Nah, Adi, sorry. Yeah, it's there on the graphics calculator, right? So you can just kind of use that as a shortcut to try and do it. So when we get to a locus question later on, I mean, if we do another one tonight, we can actually try and do like show you guys how it actually works in the calculator. How should my calculator be set up going into the exam? Combat, I think you can go with the radians, man. I don't think it really matters because most of the questions you can actually do it without a calculator. But yeah, Annika, don't stress. I mean, you got plenty of time. You got 4 days left, and we've been doing excellence questions for the last few nights, and we'll probably continue again tonight, so you can kind of catch up. All right, let's do this question here. Now, this question here is asking us to find just the value of b. Now, this is actually a lot more easier than what you guys actually think, because it's like, I'm going to show you guys how to do this in the calculator. And don't worry about it. It's not like you're going to get pinged for it or anything like that, right? So because 3 minus 4i is a solution, what you could do is you could actually go 3 minus 4i is equal to z. And because z cubed, it's a solution, we know that we can actually substitute z in there, and that whole equation should equal to 0. So in other words, 3 minus 4i cubed minus 8 times 3 minus 4i squared plus b times 3 minus 4i minus 50 is equal to 0. So what I'm going to do is I'm actually going to put that all of those other things in the calculator, because it doesn't actually tell you in this question to show you any working. It just says find the value of b. So what I'm going to do is I'm going to put down 3 minus 4i. And by the way, this is another trick that you guys can actually do. So you can actually go alpha and choose b, the letter b, for example. And I'm going to put it as 3 minus 4i. Now this actually saves you guys a lot of time. Oh, sorry, that's the other way around. let me try that again. 3 minus 4i, and I want you to store it as the letter B. Maybe not B. It's terrible letter. Let's go with alpha A. Basically what that means is now the calculator has actually stored the letter A as 3 minus 4i. And because it's 3 minus 4i, what I'm going to do is alpha A to the power of 3 minus 8 times alpha A squared minus 50, and I'm getting this right here. So basically what I've got here is this, all of this thing, I actually put this straight in the calculator to actually get minus 111 plus 148i plus b 3 minus 4i equals to 0. So of course in my next step I'm obviously going to take those numbers to the other side, which means I'm going to get negative 111 plus 148i, and at this point I can actually say b is equal to negative 111 plus 148i divided by 3 minus 4i. Now with 111 and 148, look, I'm going to be honest, there's got to be like a common factor, right? But what you can do is you can do a bit of a cheat, because you could actually go, you know, I'm just going to put this in here. Negative, that should be minus, sorry, plus and minus, my bad. Thought I made a mistake. Yeah, positive, thank you. So what I'm going to do is I'm going to go 111 minus 148i, and I'm going to divide it by alpha A, because I already have that stored. And notice how it's 37, right? So what I could do is I could be a bit cheeky and just do this as a step. I can go 37, 3 minus 4i, and then 3 minus 4i, and because they cancel out, I can write this as b is equal to 37. Yeah, Finn, today we're going to do complex numbers just for the merit questions, and then after that we'll do some excellence questions, which will be slightly different. Now, Adi, some of the questions it does require working out, right? I know which one you're talking about. Some of them you need to kind of play around with the numbers to try and figure it out. But it really, like, even those ones, I think you can actually do it in the calculator, but it's just you got to be a little bit cheeky about it, like, so that you can kind of, you're trying to pretend that you know what you're doing, but in fact you're actually using the calculator for it. Yeah, Henry, sometimes you get a question like that, and I'll tell you what, like, I think we might do like either on a, I'm trying to think when I'm going to do it, like probably have to cook a lot of food this weekend if I'm going to run like a long tutorial, but like I wouldn't mind, how do I say this, you guys have to like basically just send out like a, what do I call it, yeah, you got to help me talk to my management at home, man. Like if you want me to run a 3-hour tutorial, I can do that, that's not a problem, but yeah, it just means like I got to do a lot of cooking at home first, because got to keep my wife happy. Yeah. Why did you change the negative and positive signs? That's just rearranging, Adia. I was just rearranging there. Nah, Adi, that's not an excellence question. That's just your normal kind of questions, right? But I wouldn't I wouldn't mind doing like on a Sunday, doing like a massive merit marathon tutorial, or even on a Saturday. Yeah, Tom, I think when you do it by hand, it does take a very long time. But there are shortcuts again, like you get to kind of learn some of them. All right, let's go to the next one, guys. Question D, and I think that's pretty much all of our 6 merit questions there. Then we can actually try and do one more complex roots, as you guys were saying. Oh, come on, we're doing this again now. I think next time I'll just paste the questions instead of pasting the whole sheet. All right, so this is the last merit question that we're going to be doing. Talpa, yeah, you're right. On the occasional time, I don't think I've ever seen C question as an excellence. I've seen a D question as an excellence, but usually the last question of the, your 3 sub questions generally tends to be excellence. Yeah, this whole proof question just keeps coming back, right? Like if you ever get this question, all you got to do is just put u is equal to, oh, you got 2 complex numbers. Okay, so you probably would go like a plus bi and then c plus di and then try and figure it out. Oh, did you? I can't remember C. Oh, Ravine, I had such a crack up lesson today because like I teach a bunch of year 8s and 9s, right? And so they today we're doing measurement, and it's like I enjoy it. It's good fun with these guys because it's like I can do the kind of the crazy calculus and algebra in the nighttime, and then have a little bit of chill out maths with the kids, just doing things like area of a square and rectangle. And what was I doing the other day? I think the other day I was doing like adding fractions. That was great fun. Nah, the West, I think you should be all right, but I think you'll be all right. Like just leaving it as decimal points. I don't think they're gonna ping you too much for rounding. Neither, Henry. The highest maths I actually... Okay, let me put it this way. Officially, the Ministry of Education is paying me to teach year 9 and year 8 maths. That's the highest maths I'm teaching at a school right now. Yeah, that's right, Adi. Thank you for that. It's a good point. Sabo, I wish I could answer that question, but it was actually given to me by a friend of a friend of a friend of a friend, I believe, who went somewhere else, and yeah, long story. There we go. There's always someone with a link. Chuck it up, Adi. I'll approve the link. Sometimes it doesn't work if you post links, but if not, yeah, just flick it to my email and I'll post it up here. All right, guys, we're gonna do this question real quickly because I think you guys were wanting to do complex roots, so we'll try and do one more complex roots question after this. So what I'm gonna do is I'm gonna put down u is equal to a plus bi, and v is equal to c plus di. Nothing special here, right? I'm just putting them as 2 separate letters there. And what I've got here is, first I've got a plus bi multiplied by c plus di, and the conjugate of that is what I want to find out. So I'm going to actually expand the brackets. So I'm going to get, so let me actually get rid of the conjugate first. So I'm going to get ac plus adi plus cbi plus bdi squared. And so I'm going to get AC plus ADI plus CBI minus BD. All right, so I'm going to get my real values here, which is AC minus BD plus ADI plus CBI. Now, at this point, what I'm going to do is I'm going to put down the conjugate of it. Shall I put down the conjugate of it? Yeah, I'm going to put down the conjugate of it. So if I put the conjugate of this, then what's going to happen is I'm going to get AC minus BD minus ADI minus CBI. So basically I'm just changing the negative, the imaginary parts to the opposite symbol, right? So this is actually UV conjugate. Now when I do U conjugate times V conjugate, U conjugate is going to be A minus BI multiplied by C minus DI. So I'm going to get AC minus ADI minus CBI plus BDI squared. And AC minus ADI minus CBI minus BD. and then I can write it as AC minus BD minus ADI minus CBI. And as you can see, both of these things are equal. They're the same. So I've literally just proved that it works. So this is what a merit question, all right? And it was a pretty neat little little proof there. And that's pretty much it for this paper, because that's pretty much all of our merit questions that we did. And I think if you look at the time wise, you know, we talked a lot and we took about 40 minutes to do it. So yeah, so I think as you do more of these questions, you kind of just start learning to power through them. But let's pick up a complex roots question from which one are we doing? 2016 or 15? Complex roots, 2015 question. Okay, so because you guys want to do, am I right in assuming that you guys want to do one more complex roots question? Or do we straight away want to move into the excellence ones? All right, try this complex numbers question here. So what we've got here is I'm just gonna put the question up here for you guys, and then you guys can have a go at it. I'll be back in like a couple of minutes. So z cubed equals k plus square root of 3 ki. But before we do this question, I might actually give you guys another question to do first, and I'll come back to this question as well. So we'll do a couple of questions, complex roots. Okay, try this one here. Solve z4 equals negative 4k squared I. Actually, do this one first. Do A first, and then do B. Smiley, come on. You can aim for merit. Don't just settle for achieved. Same with you, Sabo. You gotta aim for a little bit higher than that. And I think as you start working through the questions, you're gonna find them easy, and you're gonna be like, I can't believe I was aiming just for achieved. Same with you, Zach. Yeah, sorry, K is real. For both questions, K is real. Alright, be back in 2 minutes, guys. Right? All right. All right, guys, so we're going to do both of these questions real quickly, and then after that I'm going to switch streams to the excellence questions. All right, now I'm going to do both of these questions right next to each other so that you guys can actually see the difference for these questions. Okay. Well, I don't know about that, Henry, but she does say, it's like, you know, you need to go do this stuff, so she'll just be like, go. I can't see it, Sabo. Can one of you guys actually email it to me? Then I can actually post it here. No worries, Matt Vella. You're welcome. Yeah, I do, Ben. I've got a 6-year-old fella. There's an interesting comment that we had a conversation today about maths, and he's like, Dad, like, he basically says that mom teaches better maths to him than me, and I'm like, yeah, okay, that's fine, man, that's all good. Yeah, Adi, yeah, send it there. Hey Stacy, how was your exam? You can write cis 0, Tom. Nah, Ben, no, he's not, man. Like, it's you know, you don't actually see, like, how do I say it? It's just like, I just let him be what he wants to be, right? Anyway, let's go through this, all right? Where was I? Z4 equals 4k squared I, right? So I'm going to write this down as, I'm going to draw it real quickly. So Z4 negative 4k squared I this time. So because it's I, it's in the imaginary section, that's where negative 4k squared is. So my complex number is going to look like that, and because of that, all right, let me just have a look. I think I just got it. I saw 426. There we go. So we can actually say that this is going to go around 270 degrees, and someone earlier was asking me about, can I put this as 270 or minus 90? So you could actually put this as 270 degrees. So my Z4 is going to equal 4k squared cis 270 degrees. Now, with that in mind, what I do next is I actually write down what Z1 is. Z1 is going to be 4k squared to the power of a quarter cis 270 divided by 4. So Z1 is actually 4k squared. Can't be. You know, the truth is, like, you can actually simplify this, but you can also leave it like this. But, like, I mean, if you want to simplify it, I would go 4 to the power of a quarter, k to the power of half, and you're going to get cis 270 divided by 4. What is it? 135, 67.5. Is it? I don't know. Head is not working at the moment. What is it? 270 divided by 3. No, 4. Yeah, 67.5. So, there the negative goes away because it's modulus. So modulus is always a positive value, right? So if you think about it, we're looking at the length, and length can't be negative. So then Z2, Z3, Z4, and all it's going to be is all of these parts are going to be the same. So 4 to the power of 1 over 4, k to the power of half, k to the power of half, k to the power of half, cis. Now, because you've actually got 4 roots, you're going to add 90 to all of your z's. So this will become 157.5, 247.5, and 337.5. And we're pretty much done with this question here. Sorry, I didn't realize that all my other stuff was there. So that's what this is going to look like. Let me know if you're okay with that before I carry on with the next question. Yep, you can use under the C, you can use minus 90, because if you use minus 90 and you divide it by 4, you probably will get minus 22.5, which is the same thing as saying 337.5, because minus 22.5 is like that. No, wait. Yeah, like that. And 337 is all the way around. So minus 22 is like there. So you can use minus 90 and you'll still get that same answer. Like I said, so like some teachers like to work between minus 180 degrees and positive 180 degrees. And some people like to work between 0 and 360. And to be honest, either one of them is correct. So you're good to go. Shall I go on to question B, or what do you guys, how are you guys feeling? Do you need any more questions answered? Okay, so I'm assuming that we're good here and that we can actually go to question B. Now, with B, is really important that you recognize this, all right? Recognize what? Let me open up a formula sheet. Right here. Okay, so what we've got in this one is you've actually got to do a little bit extra work for this before we get to our the main first part of it, right? Because what we've got here is we've actually got z cubed equals k plus. Now we're gonna have to draw a little diagram, and what we've got here is we've actually got k on this side and square root of 3k here. And so this is where the point is going to be at. Now the problem is that you don't know what that angle is. Now with the other ones you can actually go, right, it's 90 degrees or 180 or 270. But in this case you actually need to figure out what the angle is. And what I really want you guys to have a look at, and the clue is right here. You've actually got 1k and then you've got root 3, which means if I go into my formula sheet, right there, you can see that you've got a 1 and a root 3, and then there's the angle, which is pi over 3. All right, so what we're going to do is we're actually going to use this triangle and we're going to rewrite k and the angles itself. So if you look at the triangle, you've got 1, root 3, and 2, and then you've got 60 degrees here as an angle. I'm sorry that's not as zoomed in. Let me just zoom in a bit more. There we go. Let's go back. So you can kind of see it. So there is my 1. So that's going to be 1k. This is going to be root 3k, which means the modulus is going to be 2k, and the angle is going to be 60 degrees. So we're going to come back here, and hopefully you guys can see that connection of 2, 1, root 3 and 60 degrees. So then I can rewrite this as z cubed equals to 2k cis 60 degrees. Now let me know if you're okay with it, because if you're not okay with it, then I'm sorry, the rest of the question is not going to work out for you. Sometimes they do this variation as well. All right, I'm going to finish this question and I'll show you the other variation of this question. So z cubed is that, so z1 equals 2k to the power of a third cis 60 divided by 3. So z1 equals 2k to the power of third cis 20. Because we've got 3 angles, we are going to add up 120 to each one of them. So we're going to get this is the same, we're 140, these two things are the same, and we're going to get 260. But please do not put the apostrophes like I did. I'm just being a bit lazy at the moment. When you guys are doing it, make sure you write the 2k. You know, I just realized I could actually just do this. I should be able to do this. Is it going to work, or is it too complicated? Is it going to be working? It's too complicated. I can't be stuffed. But yeah, so that is what you're doing. Like I said to you guys, there is a third situation where you might get something like this, where they'll say, z to the power of 4 equals 3k minus 3ki, for example. All right, or even actually they might even do something like this. Would they do 3k? Yeah, like let's say 3k minus 3ki. Why is it 2k and not just 2? Well, if you think about it here, Uday. So you've got 1 root 3, right? But theoretically, we've actually got 1k, we've got root 3k, therefore this has to be 2k, because it's like increasing it with the same proportion. So it's kind of like similar triangles if you think about it. If I have a triangle like this, which is k root 3k, then this is going to be 2k, because they all have the same proportion, which is 1 root 3 and 2. It's crashed. Hopefully that kind of hopefully you got that today. Now what about this other situation? So if you're using radians, what would you add to the angle for each solution? So if you have like 3 roots, because each angle, like you have 2 pi in a thing, so like in a kind of, what do you call it, 2 pi around a point, so you're going to be adding 2 pi over 3, 2 pi over 3, and 2 pi over 3. And if you look in the first situation, it's actually pi over 2, pi over 2, and pi over 2. So that's what you're going to be adding. I don't think I have anything like that, ML. Like all I've been doing is just like tutorials. And look, the last one I want to do is this one here, which I just want to show you guys. Now, when you draw this, what you end up with is actually an isosceles triangle, because you've actually got 3k here, minus 3k is here. So what you're ending up with is something like this. Now it's 3k and 3k, so it's actually an isosceles triangle. So if you look at the proportions, we are looking at 1, 1. So if I go into my special triangles, I can see that I've got 1, 1, square root of 2, and pi over 4 is 45 degrees, because it's an isosceles triangle. You got 45 degrees there. That adds up to 90 and 90, 180. All right, so we've got, if we ever see 1 and 1, then you know that the modulus is going to be square root of k in this case. So we're going to go back and I'll show you guys what it's going to look in this case. So if we look at it, because our triangle actually looks like this, we've got 3k and 3k, and this is going to be 2 times 3k, which is 6k, but it's actually going to be, and actually no, let's try this slightly differently, hang on. So if I had 1, 1, root 2, then I think this would just be root 2 times 3k. I made a mistake with that, sorry about that. And as for the angle is minus 45 degrees, or if you go all the way around, we're going to get 315 degrees. So your Z4 is equal to root 2 times 3k cis 315 degrees. So hopefully that's pretty much all of your what do you call it, all of your complex roots questions answered today. If you guys got any more questions, I'll hang around, like literally I'm just going to set up the next stream, which is going to be the excellence stream. So just give me a yell out if you have any questions for that. Otherwise, I'm going to swap streams to go into the excellence one. Help desk. What's today's date? Is today 9th or 10th? Oh, it's 10th. Oops. 10th. Stein, I'm gonna maybe do that later in the week, man. Today I just wanted to do the merit questions for complex numbers. Maybe if I don't know if I'm gonna come on tomorrow. Depends how I feel at the end of the night. But we will. Hang on, just want to check a couple of things first before I forget. Stream settings. I put it at low, which is okay. That's working fine. Can you give us all the Z questions for the last one? Yeah, I could do that. Change dashboard. Hang on, something's happening here. I think I might have botched something here. That's all right. November 10th, 10:45, 10. You could try Uncle Terry, but like I said, I've got to do the level 3 ones first, and then I'm going to actually get on with the next one. All right. So by the way, for solving this, we're going to get root 2 3k to the power of a quarter, cis 315 divided by a quarter. So whatever that is, 78.75. Like, look, I actually made up this question, guys, so it's not gonna have like pretty numbers or anything like that. So 78.75, and because this has 4 roots, we're gonna be adding 90 every time. So the next one would be 168.75, the next one would be 258.75, and the last one is going to be 348.75. So those are your 4 roots right there. Give me 1 second. All right, where did I mess up last time? Can you give us solutions? Vivian, how did I find the modulus? Where did we go? Modulus. How did I find the modulus? I just used this, I used the special triangles for that to try and get to the modulus for that, Vivian. Square root. Yep, Mango, you could do that as well. Sabo, you can actually do both. It's fine. Like, you can actually go minus degrees or positive degrees. Noah, we just did complex numbers, what do you call it? Merit questions. But I'm going to stop the stream right now, and I'm going to jump over to the other stream, which is going to be excellence questions. Those excellence questions, we're going to be doing like 1 differentiation, 1 complex, and 1 integration questions. All right, so I'll switch over, and I'll see you guys on that other one if you're coming and joining me. Catch you soon.